Okay, so we start with just what this one's called, this section is just called angles. So we're laying the foundation for a lot of what we're going to do moving forward. So the degrees on a coordinate plane is how we start. If you could take a coordinate plane and overlap it in a circle, the idea is the degrees would come all the way around. So we start with angles. Obviously, we've got our x-axis, we've got our y-axis, right? If I asked you to draw an angle, you would start, this is called the initial side, would always be to the right where x would be 0. And then the terminal side is where that angle ends. So this is a positive angle rotation. It goes counterclockwise. So it goes opposite your clock, okay? It goes around to the left. This little symbol here is called theta. It is one of the many Greek letters that you're going to see. There's some good college prep because every sorority and fraternity has Greek letters. We're going to learn some vocab too, okay? That's called theta, and it's just the name of an angle. So it's like a circle with a little fancy thing on the inside, okay? If I said 90 degrees, you'd start it here and you'd go up straight where that would be 90 degrees, okay? So that's a positive angle. Negative angles go in the other direction. So they still start in the same place. My initial side is still on the right at 0, 0. But this time they go clockwise. So this would be like a negative, I don't know, like 45 degrees. And this would be like a positive 45 degrees. So positive goes around to the left, counterclockwise. Negative goes clockwise. So it starts by moving down. Okay, coterminal angles are angles that have the same initial side and the same terminal side, but more or less rotations around the circle. So if I said, I'm going to give you an angle that's like, let's just say it's 30 degrees. And then I said, give me an angle that's 390 degrees. I'd start at the same place. I'd go all the way around one circle one time, that's 360 degrees. And then I'd go 30 degrees past it, and that would be 390 degrees. So if they start and stop at the same place, they're called coterminal angles.
Wouldn't they always start and stop at the same place?
Well, no, I could just have like 30 degrees and 45 degrees. 30 degrees and 45 degrees are two different angle measurements, right? Those aren't coterminal. Coterminal angles will always start and stop at the same spot.
Oh.
Right. So the way we find it is if I'm given an angle, I add or subtract 360 degrees. So if I want a positive coterminal angle to like 30, I add 360, and I'd get that 390. If I want a negative coterminal angle, I'd subtract 360. And I'd get negative 330. God bless you.
That was nice.
Oh, I take it back then. Well, you literally just started. Make it your friend.
I already don't get it. Then what happened at the same side?
So I'm going to draw two lines, right? I'm just going to crisscross. This is 0, yes? If I go all the way around, it's 360 degrees because that's a circle, right? A circle is all the way 360 degrees, right? So if I said, we're gonna get to this, but this would be 90 degrees at the top, right? On the left would be 180 because that's a flat line. Go back a little bit halfway between 180 and 360, and that's 270. So these are called your quadrant angles, and we're gonna get to know these really well, right? So if I said draw something that is 60 degrees, I start here, because that's where I always start. 60 degrees is a little bit less than 90, yeah? So I'm going to say, like, maybe it's there. That's 60 degrees, right? If I want a coterminal angle to that, I add a whole circle. So I add 360 degrees, and I get 420 degrees. So if I wanted to graph that, I'd start the same spot. I go all the way around my circle, 360 degrees, so one full circle, and then I go 60 more past it. And it looks like the same angle. I just went around one more time.
So, to get, like, the coterminal
Correct. Or minus 360. Because if I want a negative one, I subtract. So that goes this way. This would be negative 90, negative 180, negative 270, negative 360. So I'd go just past negative 270 for negative 300.
So you're just putting it in the same place.
Yep, those are coterminal. If they're coterminal, they're the same.
Coterminal is just you put it in the same place and circle around.
One more time, one less time, two more times. I could do it again. I could say, what's another one? Add 360 to that again. 780 would be the same angle, just around one more time. Yep. Sophia.
Why did you put 30 on the one above it and then you put 60 on that one?
They're just two different ones. So see how 30 is smaller than the 60. This was one example.
Oh.
So 60 would be here. There's 360 degrees all the way around there. So I could ask you to eventually graph 170 and you would want to know where that is. I could ask you to graph 200 degrees and you would figure out where that is. So what's important is this too. A positive coterminal must be positive and a negative coterminal must be negative. So let's say that I ask you to find the coterminal to 420 and I say give me a negative coterminal angle, right? Normally to find negative we subtract. If I subtract 360 from this, I get 60. Is that negative?
No.
I'd have to do it again. So if it says negative, you go until it's negative. If it says positive, you go until it's positive.
So when we're doing coterminal angles, are we drawing a picture every time or no?
Mm-mm.
So because of that, that's why we have to go until it's negative or go until it's positive.
Correct. It'll say give me one positive and one negative coterminal angle.
So you just put like if it says like for example, give me a negative coterminal 420, you just write negative for 300.
Yep.
I didn't-
We're going to make it your friend. I'm going to force it. All right. So this one says find two coterminal angles, one negative and one positive. So I'm going to start with number one. What do I do to find a positive one? I could add. I could also subtract. So there are more than one answers to these, right? I could just subtract 360. And I get 548. Is that a coterminal angle to 908?
Yeah.
Yes. Is it positive? Yes. So this could be one of my answers. Now I need a negative.
So to be a positive coterminal angle, it just has to be positive.
I mean, plus or minus 360, but yes, it has to be
To be a negative, it just has to be a negative.
correct.
Right? It just-
So if I take this and subtract 360 from it, 188, that would also be a positive coterminal angle. I haven't gotten negative yet, right? One more time. Well, I don't know why I wrote that. I know I need to switch it. Sorry. Negative 172. So there can be more than one answer for these, but the positive has to be positive. Either of these would have worked. You could also have added 360 to that. It still would be right. The negative has to be negative, and it could be negative 172. I could subtract 360 from that again, and it's still negative.
How's 188 minus 360, 28?
No, oh no, I started to write it, and then I said I don't know why I'm doing that way. I have to switch the order.
Oh, okay.
Yeah.
It's like-
No.
So if it's already negative, then
We just stop at the first negative one we get.
Sure.
So the answer would be 172, negative 172.
It depends. What if it's really, really negative? You only need one positive, one negative, but the positive has to be positive and the negative has to be negative. So sometimes you're going to add 360 more than one time, and sometimes you're going to subtract 360 more than one time before it becomes.
So you stop once you get to.
Once you get to what you, yeah.
Okay.
So negative 203. If I wanted a positive, I do what? Add 360. So this is really 360 minus 203. $157, and it's positive, right? So that's my positive coterminal. If I want a negative one, I'm going to subtract 360. And that time we only needed to do it once. I skipped 2. I went out of order. 2, negative 75. How do I get a positive? Add 360. $285. And a negative. Subtract 360. All right, so what can I do with 699? Subtract 360. And that's positive, so that works for a positive coterminal. And then subtract 360 again. Negative 21. And that's your negative coterminal. So if I was to graph any of these, you would see them literally overlap. They'd go around one more time or one less time. See if it says to graph. I can't remember if it said to graph. No, just find it. Oh yeah, sketch. Okay, so let's practice the drawing this out, okay? So let's say I start with, let me start with something. Let's start with positive 75, because it doesn't, I think I went straight into it, yeah. No, because that's actually in your homework. Sorry. Let's start with 80 degrees. So when I draw this, remember that those quadrant angles, I just said let's start with that. Like, I just threw it out there. This is 0, this is 90, this is 180, this is 270, and then it comes back around to 360. So that's my full circle. Those 4 are called quadrant angles. So if I wanted to draw 80 degrees, I would start with my angle on the right, because that's where I start all of them. And I would go just shy of 90. It doesn't have to be perfect, but just shy of 90, and let's say that this is 80 degrees.
You have to have like the little arrows on the pole.
Yeah,
Clockwise is negative, counterclockwise.
correct. So now let's find a coterminal to 80. Let's find a positive one, add 360. 440. What's it going to look like? The exact same thing, but I go around one more time. So I could start here and go all the way around. That's 360 plus another 80, and I'm at the same spot. Then let's say I want to do a negative coterminal. So 80 minus 360, negative 280. Negative goes, I'll show you 2 ways to draw negative. One is go count clockwise now. So this would be, I'd start the same spot. This would be negative 90, negative 180, negative 270, and then just past it would be a negative 280. So one way to draw a negative is go clockwise all the way around. So I started here. If I'm going negative, then these are reversed, right? The 90's at the bottom. This would be negative 90, negative 180, negative 270, and then I go 10 degrees past it. And that would be negative 280.
So this is all in the same spot.
Yep, they just switch. Oh, the coterminals are always going to be in the same spot.
But you have to draw the arrows?
But you do the arrows around one more time or one last time or one, whatever it is.
So you have to draw like the circles.
Correct.
Is this homework on website?
No, none of the
I
chapter.
was gonna say, how do we do that?
None of the chapters on WebAssign because it's not in that book.
Yeah.
Okay, so that's one way to do a negative. I'll show you one more way because sometimes it's more helpful. The other the way to draw a negative is draw it as though it's positive. So if I wanted to draw a positive 280, I'd go from here, I'd go 90, 180, 270, just past it. That would be a positive 280. And then fold your graph in your mind like a hamburger top to bottom along the x-axis. So if I were to actually fold this down, like take this and fold it, right? Wherever this would align with on the top is where the negative would be. So it would be here. So again, if I fold it along the x-axis, wherever that line lined up with the top would be the negative version of that angle.
Wait, what was the degree of that original angle?
They're both negative 280. So it doesn't matter how you see it. You see it however you see it for negatives. Okay, but you're going to have to graph negative, so make sure you train your brain. Either go clockwise or go regular as though it's positive and then fold it.
Because positive,
Goes counterclockwise.
yeah.
Yeah, and then negative would go clockwise. Yeah.
So it's like the numbers, like the 0 to like 90, 180, 270, 260. And then 0 and 360 always on the right, and then 180 is always on the left.
Correct. Yeah, always, always, always.
Doesn't matter.
The 90 and the 270 flips when it's negative.
I know you just been throwing me to explain again. Why do we have 2 lines on the third? Why for everything?
I drew it as though it's positive, and then you fold it in half, like this, and where it overlaps would be where it's negative. So if I asked you to draw negative 30 degrees,
So if it's positive to start with, you put it there and then
you leave it alone.
draw it positive again and it goes there.
If you want a coterminal, yeah,
And then a negative,
you go the other way.
and then it's gonna end up in the same place.
Right.
So the only reason you squish it together is you get the negative,
So there's two ways to graph a negative. I'm going to show you both again. Ready?
but the reason to get the negative is because,
The actual angle you were
It's
finding was
already
negative. Right.
okay.
So let's just say I give you just this question and I say graph negative 30. You have two choices. Start at 0 and go clockwise till about 30. That's negative 30. The other option is graph it as though it's a positive 30, which is about here, and then fold it like a hamburger. Where this overlaps along, like fold it along the x-axis, would be the same angle. So you choose whichever way your brain sees that, you choose, okay? And if you want to flip-flop between them, do it. But you are going to, so the last part of the homework is just going to say, it says sketch each angle in standard position, which means their normal position. Draw an arrow representing the correct amount of rotation, so if we need to go around more than once, or we go negative. And then find the measure of two other angles, one positive, one negative, that are coterminal. Then it says, give the quadrant of each angle. So remember, this is first quadrant, this is second quadrant, third quadrant, and fourth quadrant, just like our normal coordinate grid. And if it falls on the axis, we say x-axis, y-axis.
What number is that?
5. No, oh, I'm sorry, 4, the one over on the right? The IV, is that what you mean? Or you mean what number is from the homework?
No, like on the page.
Yeah.
So why does it look different than? I'm really confused.
Those are the quadrant numbers. 1, 2, 3, 4.
And it's negative.
It's Roman numerals, yeah. What?
If it's negative, would it be off?
The quadrant's still the same.
Okay.
Yeah. You just
Have
go the
to write
different.
those?
It says give the quadrant of each angle. So 61, 63, 65, and 67. Sketch it, coterminal, and then give the quadrant of the angle.
Okay.
Questions on those? What's weird is like this is at the end of your homework, and then it goes back to where it starts where we're about to do. It's very out of order, but.
In any graph with the quadrants, is that always how it is? 1,
Yep.
2, 3, 4?
Yeah, that never changes. Yeah. Okay, this part, you're gonna need a calculator, and I'll show you how to do this with the scientific calculator, and I'll show you how to do this in a graphing calculator because it's much easier for some. And this is going from something called degree, minute, second notation to decimal degree or vice versa. It looks crazier than it is, okay? So decimal degree, if I could spell that right, is that right? How come that looks weird? Oh, because there's a dot over it. I'm like, that looks super weird. Decimal degree is our normal angle. So if I said 32.5 degrees, that's decimal degree. Degree, minute, second notation looks like 32 degrees, 30 minutes, 45 seconds. It looks like that. The first thing is obviously always your degrees. It has a degree symbol. The second thing has a single tick mark, and that is minutes. And the third thing is a double tick mark, and that is seconds. So you're going to learn both how to get from decimal degree to degree minute second and how to get from degree minute second to decimal degree. To get from decimal degree, like normal, to degree minute second notation, we're going to take, no, sorry, this is the other way around. This is degree minute second. Yeah, switch, those are, oops. Those are switched. Degree minute second to decimal degree. So to find this in decimal degree, our normal thing, we leave the degree alone, so 32 stays as 32. The minutes are how many minutes in an hour? How many minutes are in an hour? So I take that 30 and I divide it by 60. The seconds are how many seconds are in an hour? How many seconds are in an hour? It's 3,600. So I do 40.
It's right there.
It is right there. Divided by 3,600. So I take the minutes, I put it over 60 because that's how many are in an hour, and I take the seconds and I put it over 3,600 because that's how many seconds are in an hour.
These are these just numbers that you just.
Yeah, like I just said, if we're gonna use this one.
What's the number below the 5? 3.5.
Yeah, but that's not the equivalent. That's just an example of what degree of decimal degree looks like. So these are not the same. I was just showing you that this is something in decimal degree and this is something in degree minute second notation. So now we're just looking at the 32, 30, 45. So I would do 30 divided by 60, which is what? 0.5. And I do 45 divided by 3,600, and I get 0.0125. And then to get the full degree, decimal degree, I just add those together. 32 plus 0.5 plus 0.0125. And this becomes 32.5125 degrees.
And it's written in, so we take it from.
That's in degree minute second notation into decimal degree.
Okay, so degree minute second to decimal degree.
Yeah, the reverse of what this says. This is switched. Okay, it's switched. So if I go degree to DMS, then I take the angle, whatever it is, plus the minutes over 60 plus the seconds over 3,600. And then I just add them all together.
Wait, will it always be over 60?
Yep, because minutes are always over 60 and seconds are over 360. Okay.
What is the DMS?
Say again?
DMS?
Degree minute second notation.
Oh.
So then to do it the other way.
So now to go back the other way, that's this part. We take the degree. So if I'll use this one so we can check our work. I take the degree, which is 32, and that's,
Tell us
the degree. You would either get it in degree minute second notation and you're going to convert it, or you're going to get it in decimal degree and you're going to convert it.
If it gives it to us in degree minutes second, and we convert it, it's gonna give us the degree.
Yeah, it looks just like this. It's in degree minute second notation.
I mean, if it gives us in decimal degree,
It would be just like this. The first part is the degree.
so it's in front of the decimal point.
Is the degree.
And then everything after that.
And then we do
is
this.
second.
Then we take the decimal, so we're going to take 0.5125, and we're going to multiply it times 60. So I'm going to take 0.5125, which is the decimal part. I'm multiplying it times 60, and I get 30.75. Now the whole part of that is 30. We take that and make it the minutes. And then we take the decimal part of that, 0.75, and we multiply it times 60 again. And we get 45, and that's the seconds.
I'm gonna try and make this make as much sense as possible, my question.
I'm going to work it out a couple more times, but that is how you do it.
Okay.
Yeah.
I hope my question makes sense, but, so, like, the symbols that we have for, like, our minutes, second, and
Yeah.
degrees, is like, so every time we get a decimal point, you put a symbol.
Correct.
So, like, with the 32,
That stop, the
Symbol
32 is the degree. Yep,
and then you solve, you put a symbol for
Correct.
minutes. You solve,
and you're done.
you put minute for second,
Yes,
or seconds, minutes, no, minute, second.
minutes, seconds, yes. All right.
I know when there's no graphic. I don't know.
What form is this in?
The first one.
Degree, minute, second. DEMS, degree, minute, second. Yes, we know that because it has a tick mark and a double tick mark. Yes? Even if it only has one tick mark or two tick marks and not the other one, it's still degree, minute, second. So how do I convert this to decimal degree?
Add, divide, add, divide.
So I'm going to take 74 plus 8 divided by what? 60 plus 14 divided by 3,600. So 8 divided by 60 is 0.13 repeated. I'm leaving that in my calculator because I want to keep it as exact as possible. To that I add 14 divided by 3,600. And I get 0.1372 repeated. And 74 is the degree part of that, so that gets on the front. So it will say, I think, let me tell you what it says to round to. It will say what to.
When doing it in a graphing calculator, do we have to put the 14 divided by 3,600 in parentheses?
No, because the division will come first. It will do the division and then it will divide, and then it will add.
I got 1372.
I have 1372.
It's a little awkward.
14 divided by 3,600. Yeah, 1.372.
Yeah, I'm thinking.
Okay. It says to round to the nearest thousands. How many is a thousand?
3.
Tens, hundreds, thousands. So we cut it here.
I got it.
Good. Yeah.
You have to you divide it and put 1.33. Can't you just put the whole thing in the calculator?
Yeah. I was saying that's what I got. I would not have actually rounded it. I would have kept it in the calculator. Yeah. All right. You do it by yourself.
Oh wait, you can just do the entire
You
thing.
sure can.
I'm just so nervous
I know. That's why you write it out. Because I'm nervous for you guys for tomorrow, and that's why I'm telling you to write it out.
Parentheses, if we're putting, just writing the whole thing.
You actually don't, because it's going to divide. Order of operations says do the division first and then add it.
It'll PEMDAS for me.
It will PEMDAS for you.
I love this calculator.
I like that
Or
when
we'll give
you.
you a fraction, is that?
Mm-mm.
I like
We'll give
how.
you a mixed number.
Mm-mm.
So excited.
You don't want it. You want your format.
I got it.
Oh, great, we could test
Oh,
tomorrow.
I'm so dumb.
And then calculate.
1,000?
to the thousand. 165.853.
I don't have to do anything.
I'm sorry?
It's doing like something different for the fraction.
So if you're putting in fractions,
It's really good.
yeah, and then it's forcing it. Did it do it again?
She's holding on tight.
That's divided by.
600?
So if you, so if you do, what's it, take,
And then, like, last week she gave
51
herself a
plus
third.
the plus
Shotty off her round.
divided
She's
by,
pierced both of her ears.
or
with a
the
third
fraction, it
and a
doesn't matter.
fourth.
It's
She's not
60.
and it was so funny.
I know, but you can't have both of them, if you, it will force it into
I was
that.
with her,
Yeah.
helping her like pierce it, and she did it.
Alright, now we're gonna do the other way.
She had like really random holes in her ear.
So what's the degrees on this?
34.
34. So this is in decimal degree, and we're going to degree minute second. So 34 degrees, then 0.817 times 60, 49.
Wait, where'd you get 49?
I did 0.8, I have to do the decimal times 60, and I get 49.02. So remember, the whole number part of that becomes, all right, we did the point, so we did this, right? We got this part right. We did the 0.817 times 60, and I got 49.02. I kept the 49 as my minutes. Now I do 0.02 times 60, and I get 1.2, and that's my seconds.
So you leave the decimal stuff for the second.
For the last one, yes, you leave a
Doesn't
decimal.
matter how many there are? Or
If
just
you would round to 3, if there was more than 3.
So you can't have decimal degrees, you can't have.
Decimals in the degrees and the minutes, correct.
You can have milliseconds,
Correct.
so no milliminutes.
No, I don't know if that's a thing, but no. A milliminute is a second, right, that's why we bump it over, yes. All right, so then this becomes 59 degrees, 0.08754 times 60 is 5, so this 0.08754 times 60 became 5.2524. So I keep the 5, and then I do the 2.2524 times 60, and I get 15.144. 15.144 seconds.
And the last one you just round to 1,000.
Yep.
Just need to remember, no milliminutes.
No milliminutes. Yeah. Okay, so this homework, and I said it yesterday, but I'll remind you, is not due till Tuesday. I actually don't want you to do this tonight. I want you to focus on your test tomorrow. I've never told you not tonight before, but I don't want you to. Okay, I want you to procrastinate on this homework a little bit. So I want you to review for the test. Yeah, procrastinate on that part, not this part, right? I have it. I'll make it because I didn't know if we were gonna have time to play it in class. That was silly. Or if it was gonna be a Kahoot challenge. So I'll set it as a Kahoot challenge. It's like 10 questions. They're all calculator based. They're good review questions for tomorrow. Obviously, tomorrow is not are you listening, Madison? Obviously, tomorrow is not multiple choice, so don't give yourself that false sense of security. Okay, but it will be on there. Okay, so my advice is to do the Kahoot challenge, to review the questions that were on the worksheets that were the calculator ones. Okay.
They're gonna be on our to-do list or on our modules?
For what? What do you want it on? To-do list? Okay, I'll put it on there. It won't have a submission, but
Okay, yeah.
yeah, because I was gonna offer extra credit, but I can't do that unless everybody in Algebra 2 does that. And
Can we see our scores?
yes.